Hi, in this session we are going to discuss about work energy theorem. And before discussing about work energy theorem, let's understand what is work. For that, look at this diagram. We are having a mass m, and on this mass m we are applying a force in this direction, so that there is a displacement of the mass in this direction, and the displacement is written as x, force is F, the angle between force and displacement is theta. Then the work done in this case will be W is equal to F dot x, that is equal to Fx cos theta. Then we could write dW, that is the small work done in this case, it can be written as dW is equal to F dot dx. Coming back to our work energy theorem. Work energy theorem is giving you a connection between work and energy. In order to formulate the connection between work and energy, let's consider we are having a horizontal surface. On this horizontal surface we are placing a mass m, and we are applying a force horizontally itself. There is a small distance on this mass. The small distance is dx. On applying a horizontal force, there is a small distance dx. Then the work done in this situation, it will be dw is equal to f dot dx, and that should be equal to f dx cos 0. Why cos 0? It's because the force and displacement, they are in the same direction, therefore the angle between force and displacement is 0. Therefore we could write dw is equal to f dx. Then we'll recall the expression for force. The expression for force is ma. Therefore I could rewrite this expression as dw is equal to ma dx. Then we'll recall the expression for acceleration. Acceleration is dv by dt. Therefore I could write this expression dw is equal to m, instead of acceleration, dv by dt into dx. Then on collectively aggregating dx by dt, what is dx by dt? Dx by dt is velocity. Therefore we could write dw is equal to m, instead of dx by dt, velocity, and there is a dv. Therefore it could be rewritten as w is equal dw is equal to mv, it's not dw, mv dv. Okay, then integrate this. Let's integrate this function. Therefore integral of dw is equal to integral of mv dv. So let's take initial velocity as v1 and final velocity as v2. We are taking initial velocity of the substance as v1 and final velocity as v2. Therefore what is integral of dw? Integral of dw is w. Then on this integration, m can be taken out. Integral v1 to v2 v dv. Integral of v dv, it is v square by 2. Therefore m into integration will give you v square by 2. We have to put a square bracket, then we have to write v1 to v2. Then putting upper limit minus lower limit, we will get m v2 square by 2 minus m v1 square by 2. Then what is mv2 square by 2? mv2 square by 2 is final kinetic energy. What is mv1 square by 2? It is initial kinetic energy, since the expression for kinetic energy is half mv square. Therefore we could write work done is equal to final kinetic energy minus initial kinetic energy. This is our work energy theorem. Work energy theorem is saying work done is equal to change in kinetic energy.